Hello, geometry class. I'm sorry I'm not in class today, but hopefully, although I know this isn't ideal, hopefully this serves as good substitute. I know the video quality is not the best, and this is really my first time trying what I'm trying, so let's see how it goes. Alright, normally you work on the warm-up problems on your own, but since I'm not here, we're just going to go over these warm-up problems together. Alright, so first it asks us to write a rule for the following translation. Now remember, our rule is talking about transformation notation. Transformation notation maps one point in the original figure to a new point in the image. Okay, if we take a look at number 1, we have E and E prime. So E prime is the image. So we're going from E to E prime. So we're trying to figure out what is happening to map E to E prime. Now if we take a look at the coordinates, alright, we're going forward 2 units or up 2 units in terms of x, and then down 2 units in terms of y. Alright, so every single point in the original figure gets mapped to a new point where the coordinates would be x plus 2 and then y minus 2. 2 units to the right, 2 units down. Pretty simple. Now for number 2, we do the same thing. We take a look at 2 similar points, so perhaps maybe L and L prime. Alright, L is the original figure, L prime is the image. Okay, so we'd figure out, okay, what's happening to bring L to L prime. Alright, same thing here. We take a look at what's happening with X. We're going to the right 3 units. So every point in the original figure gets mapped to a new point, and for X, we're adding 3. So X plus 3. And then in terms of Y, we figure out how much we're going up. 1, 2, 3, 4, 5. So every Y value, we'd add 5 to get the coordinates in the image. Okay, hopefully you remember that from yesterday. Now let's move on. So 4.2, we're talking about performing reflections. So when we're performing reflections, we're going to see a lot of symmetry. Okay, well, what I'm going to talk about is a mirrored image. Alright, so if we take a look at the next page here, and then you guys are going to have to fill out some notes. Alright, it says, a reflection is a transformation that uses a line like a mirror to reflect an image. So we're reflecting about that line. That mirror line is called the line of reflection. Okay, so if we take a look at the example underneath, on the first image to the left, alright, this point P gets mapped to a new point P prime. Now point P is not on M. Okay, this is one of our examples where the original figure is not on the line of reflection. Now it gets mapped exactly across that line of reflection. So we're talking about the perpendicular distance. So the distance between P and line M and P prime and line M should be the same. Okay, and it's that perpendicular distance. We're talking about a mirror image. This thing gets mapped right over line M to P prime. Okay, if point P is on line M, alright, when we reflect our image about this line, it stays exactly on the line if it started on line M originally. So P prime gets mapped exactly to its original position. Okay, therefore it's the same point. Alright, if we take a look at example 1. Alright, it says the vertices of triangle ABC are 1, 3, 5, 2, and C is 2, 1. So we're going to plot those points and draw that figure. So 1, 3 is right here. 5, 2 is right here. And then 2, 1 is right here. So here's A, B, and then C. Right, and I'm going to draw that triangle. Okay, if we were to reflect this about the line x equals 3, first we have to know what that line looks like. Alright, so we're going to graph the line x equals 3. So I'm going to take out my ruler. X is 3 right here. So I'm going to draw a dotted line that marks every place where x is 3. Alright, so this is the line about where we're reflecting. Now, these congruence transformations preserve distance and angle measure. So if it preserves distance, that means B is going to be 2 units away from that line of reflection. Alright, so the new coordinates for point B, so B prime, would be the coordinates 2, 2. Okay, if we take a look at A is 2 units from our line of reflection. So A is going to be mapped to the other side of the line of reflection, which means we'll go 1, 2 to get to the line of reflection, 1, 2 to get to the image. So A prime then is going to be at 5, 3. Alright, then finally C gets mapped across that line of reflection. So that means C prime is going to be 1 unit away from that line of reflection. Okay, here's C prime. We can form our new triangle here, which should look exactly the same as the original triangle, yet reflected about line N. Okay, the new coordinates for C prime are going to be 4, 1. Okay, we'll figure out rules in the next couple of examples so that this is a little bit easier process and we can graph these images a little bit better. Okay, for part B, we're reflecting in the line M, and M is y equals 1. So, where y equals 1, I'm going to draw that dotted line. And once again, we're taking that same exact original figure and mapping that across this line. Alright, so I'm going to go ahead and draw triangle ABC again. Alright, now our image is going to be mapped across this horizontal line. So we're still going to preserve the same distance. So when we create these new points, we should double check and make sure the distance between the original figure and the distance between that line of reflection and the image should be the same. So if we start with A is 2 units from that line of reflection, so then we'll graph A prime, which is going to be another 2 units from the line of reflection. So A prime's new coordinates is going to be 1, -1. Okay, B is 1 unit from the line of reflection, so that means B prime is going to be 1 unit from the line of reflection. So that means B prime is at 5, 0. And then if we take a look at C, C is right on that line of reflection. Okay, so if we reflect this figure about the line, it's going to stay exactly where it started. So C prime is still going to be at 2, 1. And then once again, we draw this figure to the best of our ability. And that figure should look exactly like it did before. So there's no distortion. It preserves angle and distance. Okay, because it's a congruence transformation. Now let's move on. Alright, this one's going to be a little bit better because obviously the graph is a little bit bigger, so you can actually see what I'm doing. Alright, in example 2, the endpoints of FG are -1, 2. So we'll graph that and label it. G is 1, 2. So we'll graph that and label it. And then our line of reflection is actually going to be about the line y equals x. So the line y equals x goes right through the origin and has a slope of 1. So we can graph that. Take your hand straight edge. And do the best that you can. Okay, in graphing y equals x. Because right now, we have to take a look and preserve this distance to graph the image f prime g prime. So when we graph that image, okay, G prime should be the same amount of units from this line of reflection. Okay, so we're going to estimate. If we start with G, okay, it looks like there's a half a diagonal. When we're taking a look at one of these square units, okay, we're going about halfway. So we're going to continue to go about halfway to find G prime. If we take a look at F, okay, we cross one diagonal and then we have another half. Okay, so we're going to do exactly the same thing, okay, to get F prime. So we got 1.5 units to go, so here's our half, and then here's one more, and here is F prime. Right. So when we draw this segment, as opposed to our previous segment, which I didn't draw yet, here we go, it should look exactly the same. So notice FG, that segment went 2 units horizontally, F prime G prime, it's going 2 units vertically. Okay, so it's preserving that distance. Alright, luckily though, we have some rules to do this a little bit easier. So some of you guys are visual people. I'm a visual person, so I like to do this kind of by looking at it, rotating, reflecting, translating. I like to do that using our vectors that we used yesterday, and then some other rotations and whatnot, like tetra style rotations when we get to 4.3. But here we go. We have some rules that we can use in order to perform these reflections a little bit easier. So if AB is reflected in the x-axis, its image is the point A negative B. Okay, and I'm going to write that a little bit larger so that you can see that. A negative B. Alright, if AB is reflected in the y-axis, its image is the point negative A, comma B. If AB is reflected in the line y equals x, like we just did, the image is the point B, comma A. And then finally, if it's reflected in the line y equals negative x, which would have a slope of -1, it'd be negative B, negative A. Now what this means is if we take our original coordinates, right, in this previous example, example 2, if we took our previous coordinates, okay, and perform a reflection about the line y equals x, all we would have to do is exchange the x and y coordinates. So whatever y was before would become x, whatever x was before would become y. That's what this means. Alright, if we take a look at the previous example, our new coordinates for f prime g prime was 2, -1, and then 2, +1. And what we can see between these two coordinates, there we go. What we can see between these two coordinates is that we just exchanged the x and the y values. So to get f prime, the y value became the x value, the x value became the y value. Same thing for g prime. The y value of g became the x value of g prime, the x value, the y value. So you can use these rules to better figure out where these reflections are going to end up at, so where the image is going to be. So if we take a look at example 3, alright, we are going to reflect segment FG from example 2 in the line y equals -x. Alright, so we're going to graph this just like we did before. So F was at -1, 2, and G was at 1, 2. We create that segment, label F and G. And now what I'm going to do is on the left side here, I'm going to write F with its coordinates, -1, 2, and G with its coordinates, 1, 2. And now, off to the side, what we're going to do is write down the new coordinates of f prime g prime based on the rule. So the rule states that in a reflection about the line y equals -x, our new coordinates should be -b, -a. Okay, so b is the y coordinate. So if we do negative b, we'll get negative 2, and we have to change that then to the x-coordinate. So this becomes negative 2 for the x-coordinate of f prime. And now a was the x-coordinate of f. Now we're going to change the sign, so make it 1, and now it becomes the y-coordinate of f prime. Same thing with g. Okay, so the y-coordinate of g, which is b, is 2. We're going to change the sign, so it's negative 2. And then same thing with a, we're going to change the sign, negative 1. Alright, there's going to be our new coordinates. So negative 2, comma 1 is f prime. And then negative 2, negative 1 is going to be g prime. We're going to construct that segment. And what we can see is that this is the image formed by reflecting across the line y equals negative x. Okay, what I want you guys to do, take the next couple minutes here and try out example 4. So graph triangle ABC with vertices 1, 3, 4, 4, and 3, 1. Reflect triangle ABC in the lines y equals negative x and y equals x. Okay, I graphed the reflection about y equals negative x on the left graph and then y equals x on the right graph. Now in black here is the original figure, a triangle ABC. Same thing on the right side, triangle ABC. Now using the rule of y equals negative x, we should have gotten the new coordinates. Now I wrote them a little bit bigger underneath because I thought that was a little bit too small to see. So for a prime, with the rule being negative b, negative a, what we would do is exchange the x and y values and then make them both negative or switch their sign. So instead of 1, 3, we get negative 1, negative 3, negative 1. Okay, for b, that was 4, 4, so we get negative 4, negative 4. For c prime, since c was 3, 1, we're going to switch them, which would make it 1, 3, and then change their sign. Negative 1, negative 3. All right, and graph that new figure, and it should look like a reflection about that line. Once again, distance should be preserved, so they should be about the same distance from that line of reflection. For y equals x, this one's a little bit more interesting. The rule is b comma a, which just means we exchange the x and y values. So instead of a being 1 comma 3, a prime is going to be 3 comma 1. B would be exactly the same if we exchange the x and y values. And then c prime is going to be 1 comma 3. All right, notice that a prime gets mapped exactly onto c, and then c prime gets mapped exactly onto a. So the figure a prime, b prime, c prime, that triangle, should look exactly the same as the original figure. Okay, the note up top here is talking about an isometry. So a reflection is an isometry, which just means it's a congruence transformation. It preserves angle and distance. Okay, just like a translation, a reflection is an isometry. Then finally, we end up with what's called a glide reflection. So a glide reflection is a transformation involving a translation followed by a reflection. Okay, there's two different transformations in a glide reflection. First, it's a translation that maps P onto P prime. And then second, it's a reflection that maps P prime onto what we call P double prime. Alright, the second image is just going to have two prime notations. So we'd have our original figure, our image, and then our second image after undergoing the reflection. Alright, now let's move on to the next example, which is an example of a glide reflection. Okay, so we're going to graph triangle ABC with vertices 3, 2, B, 6, 3, and C, 7, 1. we're going to translate them with this rule, which just means that we're going to move them 4 units to the left, and then finally we'll reflect them in the x-axis. Now to do this, I don't think we need to start by graphing right away. I think we could write down the coordinates for A prime, B prime, and C prime after this translation. So if A is 3, 2, after the translation, we're going to subtract 4 from the x coordinate to get A prime, which is going to be -1, 2. Okay, for B prime, we could subtract 4 from the x coordinate, and we'll get 2, 3. For C prime, we'll subtract 4 from the x coordinate, and we'll get the point 3, 1. And then using our rules for reflection in the x-axis, which just means these new points are going to be A, -B. That just means that we're going to change the sign of the y value. So for A double prime, we're going to have the same x value, and we're going to change that sign for the y value. So that new coordinate should be -1, -2. Alright, for B double prime, we should have 2, -3. And then for C double prime, we should have 3, -1. Now, of course, we could do this visually on the graph. That's how I like to do it, but I found a lot more success when we actually just use the rules that are given to find the new coordinates. So I'm going to graph triangle ABC. Here's the point 3, 2. There we go. And then 6, 3. And then 7, 1. Okay, so we could draw a triangle ABC. Now, A prime, B prime, C prime should be -1, 2, 2, 3, and then 3, 1. And it should, if you guys do it right, it should look the same. And then finally, we're going to reflect this in the x-axis, which leads us to our new coordinates, -1, -2, 2, -3, and then 3, -1. And finally, draw that triangle. Alright, so all these triangles should look exactly the same in terms of their angle preservation and their distance preservation. So segment AC should be the same exact distance as segment A double prime, C double prime. Alright, finally we get to identifying lines of symmetry. So a figure in the plane has line symmetry when the figure can be mapped onto itself by a reflection in the line. This line of reflection is the line of symmetry, such as line M at the left. A figure can have more than one line of symmetry. So if we take a look at this butterfly, we could reflect the left side of that butterfly onto the right side, and it would look exactly the same. Okay, so that's what we're talking about when we're talking about lines of symmetry. So in the next following figures, we're going to figure out how many lines of symmetry they have. So if we take a look at A, and this can be challenging because we can see a few and maybe we don't see all of them. In this figure, we're going to have a line of symmetry here. So we could map the left side right on directly onto the right side. Okay, we're going to have a line of symmetry right here. So we could map the top right to the bottom. And notice if we did a diagonal line, it wouldn't quite map onto itself. So these are the only lines of symmetry which lead us to 2. Alright, if we take a look at B, okay, a lot of times at the vertices, right here, Okay, we can see these lines of symmetry. Here's one. Here's another. And here's a third. Also, though, sometimes right in the middle of a segment, we could see some symmetry. So if we map the left side directly onto the right, we could find that we have line symmetry right here as well. Same thing in between these other two lines of symmetry. So we have line symmetry here, and then line symmetry here. So that's a lot of lines. Alright, so maybe we want to number them. We have line 1, 2, 3, 4, 5, and then 6. Okay, right here, that would be talking about this same line. So we have 6 lines of symmetry. And then finally, for part C, we just have this one line of symmetry here. Alright, so for the rest of the time remaining, you can work on your 4.2 homework. And have a good weekend.